It's basically looking at the weaknesses or bugs in a code that opens up the ability for a cyber hacker to enter and attack your code.
Welcome, listeners, to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions, who's going to introduce the subject and guest of our show today. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Susan Farrell. She is a strategic advisor for OT and industrial cybersecurity. And our topic is more or less scanning for 0 days. She's going to be talking about a Mitre repository I wasn't aware of, the common weakness enumeration repository, rather than the common vulnerability repository that I was familiar with. So, 0 days, weaknesses, not vulnerabilities. That's our topic.
Then without further ado, here's you with Susan.
Hello, Susan, and thank you for joining us. Before we get started, can I ask you to say a few words for our listeners about yourself, about your background, please?
Absolutely. And Andrew, thank you so much for inviting me to this podcast. The first 20 years of my career, I spent in oil and gas exploration and production, or upstream side of the business, working for the Halliburton software division, Landmark Graphics, worked for Silicon Graphics, or SGI, in high performance visualization of hydrocarbon reservoirs, as well as Paradigm Geophysical. Then I shifted over to IT cybersecurity, and because of my oil and gas background, that migrated over to a focus in OT ICS cybersecurity. So for the last 10 years, that's what I've been very focused on. Also, last couple of years have been focused on taking OT ICS cybersecurity that was developed for defense purposes and commercializing that for protecting critical infrastructure and nuclear manufacturing, oil and gas, chemical, etc.
And our topic today is mapping for 0 days. I've never heard of this. What is mapping for 0 days? What problem are we solving here?
So it's really interesting, Andrew. There's a lot of focus when you think about OT ICS, or industrial vulnerability management, is to look at CVEs, or common vulnerabilities. And those are the vulnerabilities in software code or firmware code that sits in embedded devices that have actually been published. There's also another layer of vulnerabilities known as KEVs, or known exploited vulnerabilities. Again, those are the CVEs that have been known to be exploited in different environments and software. What CWEs are common weakness enumerations, or it's a category system that was developed by Mitre and CAPAC that identifies weaknesses and vulnerabilities in software code, both at a hardware and software level. So when you're looking at firmware, for instance. So that is what a CWE is. It's basically looking at the weaknesses or bugs in a code that opens up the vulnerability or the ability for a cyber hacker to enter and attack your code.
I'm familiar with the CVE system and database. I am, aware of the known exploited vulnerabilities list, but, probably don't consult it often enough. But I know it's out there. CWE, I've never heard of. Weaknesses. Can you talk about that a bit more? What is a CWE?
Sure. So again, it represents a weakness in the code. So one example is a buffer overflow. And buffer overflow is the ability for a cyber attacker to over instruct code and be able to literally shut down the production of a PLC, for instance, or may over ratchet the PLC and cause it to explode, for instance. So there's even a CWE that represents malicious AI code. It's called CWE 1039. There are CWEs that represent cryptographic problems in code or a dangerous function within the code. So basically, it's just outlining the different weaknesses that a code can have in it that can be exploited. One of the great activities that I did over this past year is participated in the CWE CAPAC ICS working group, where we mapped CWEs to 62443 so that you can determine if there are any CWEs that might be resident in firmware on an OT ICS device that puts you at risk of unmet requirements from a compliance perspective.
Andrew, I'm quite familiar with CVEs, but CWEs are a new concept to me, and I'm not yet entirely clear on the distinction. I mean, a buffer overflow to me sounds like a vulnerability.
Yeah, I wasn't familiar with CWEs either, but if you Google it, Mitre CWE, there's a whole repository. There's hundreds of these things, and if there's a buffer overflow in a CVE, it says something like this PLC. If you send it that command, it triggers a buffer overflow that can be exploited to blah, blah, blah. These 17 models of PLCs run that same software. They have this vulnerability. That's a CVE. That's a known vulnerability. In CWE, there's an entry for buffer overflow that says a buffer overflow is when somebody sends a message that is usually too long, and it describes what is a buffer overflow, and it says that's it. It does not say it's in this PLC or in that web browser or in CVE is sort of specific, whereas CWE is sort of the idea, saying, well, if you're not checking the length of your buffers, you could have a buffer overflow. If you're not careful about how you manage memory, you might use memory after you free it. If you are not, careful about keeping track of your web browsers, you could have cross-site request forgery. So CWE is describing types of vulnerabilities, whereas CVE is describing one of those types is specific in these 6 products. And if you get the patch, you fix it. So in a sense, CWE is a long list of stuff that could go wrong in software. And to me, I thought it would be primarily useful to software developers saying, "Oh, I'm writing software. Here's literally hundreds of things I could do wrong. Let me go through them and see if I've done any of them." Does that make more sense?
It does. So then if I follow you correctly, it isn't that we're applying these CWEs to specific software products. They're just a general list of categories, sort of like MITRE ATT&CK, but for vulnerabilities.
I hadn't thought of it that way, but yeah, MITRE ATT&CK is all of the ways, sort of types of ways that bad guys could attack us. And, CWE is all of the, kinds of vulnerabilities that could be latent in a particular product. So yeah, in a sense, CWE is the MITRE ATT&CK of vulnerabilities. I hadn't thought of it that way. I think that's probably a good way to think of it. Buffer overflow, I understand. You said you mapped it to 62443, though. I mean, what the standard I look at all the time in 62443 is 3-3, which talks about you should put a firewall here, you should do antivirus there. it talks about security controls. It doesn't talk about vulnerabilities. What part of 62443 did you map these vulnerabilities into?
So the three different parts that we as a group focused on were parts 3-3, 4-1, and 4-2. In, for example, we were assigned a specific CWE, each subgroup. My first CWE that we mapped as a group was CWE 798, which represents cryptographic issues in code. And it was not a hard exercise to map it to specific specifications within 3-3, 4-1, and 4-2. We just mapped the wording from the definition of CWE 798, for instance, to the specific parts within 3-3, 4-1, and 4-2. And then as a result, what Mitre did is published the mapping of the CWE so that if you're looking at setting your compliance requirements, you can do an analysis of the firmware to see if any of those CWEs exist, and then determine if by continuing to use that firmware in its existing state, if it is causing compliance issues to 62443. The same can be done for 853 or 882 to map the compliance requirements to it.
Could you give me an example of that? I mean, if you look at the PLC and say, well, it appears to be written in C, that's sort of the signature of the binary and the firmware. So it is probably, somewhere, possibly, susceptible to a buffer overflow. In what sense, A, have I got that example right? And B, if I've got it right, in what sense is that a compliance violation? There's no requirement in 62443 that says your code must be free of bugs.
You're correct. But it does say that you have to practice good cryptographic practice, or it does say that you cannot have any cross-scripting weaknesses in your Industry 4.0 web application, for instance. Or it will say that if you do have a buffer overflow issue in your code, you are not meeting the compliance requirements of certain parts of 3-3, 4-1, and 4-2.
So Nate, Susan went through that real fast. Let me give you a concrete example. 62443 3-3 is the standard that applies to systems. If I have a system that I've designed in my power plant and I want it to be compliant with the standard, I would look at 3-3. 4-1 is a certified software, secure software development process. So if I'm developing product and I want to be certified as a developer of secure product, that's the standard my product development team is evaluated against. My processes are evaluated. 4-2 is when you certify actual product. If my team has produced a product and I want the product to be certified as compliant, it would be 4-2 that I'm compliant with. So, concrete example, CWE is possible, is what's, vulnerabilities that are possible. And what we're mapping is, look, if you wind up with one of these vulnerabilities, then you have a problem with this part of your compliance process. So concrete example, 3-3 has a rule, number 5.7, that, the language is complicated, but effectively it says if you're going to send a password across a network, then you have to encrypt it so that people can't just read your password. Okay. And, the example that Susan gave was a CWE saying, well, there might be a bug in your encryption process that, lets people see, decrypt and see the password. Okay. So the mapping says, look, if you have this vulnerability in your products, in your system, and that's an if. Okay, the CVE is what's actually there. CWE is what's possible. If you wind up with this vulnerability, then you would have potentially a problem with compliance with Rule 5.7 because the bad guys could use the vulnerability to steal the password. So that's my understanding of how this mapping against standards works.
מתל חי לתל אביב. המכללה האקדמית תל חי מגיעה לעשות היסטוריה עם יום פתוח בפארק הירקון תל אביב ביום שישי 31 במאי. בואו ליום פתוח באוויר הפתוח כדי לקבל את המענה הכי פתוח מהמרצים, היועצים והסטודנטים של המכללה האקדמית תל חי, לשמוע על התוכניות שלהם לעתיד, ואם תבחרו להירשם, גם תזכו לקבל הטבות שוות. יום פתוח של המכללה האקדמית תל חי ב-31 במאי בפארק הירקון בתל אביב. הסעות חינם מרחבי הארץ בהרשמה מראש. לפרטים נוספים חייגו כוכבית 9827.
I've gone to the website. I see, mitre.org, common weakness enumeration. I see a long list of potential vulnerabilities, and I can see if I'm a vendor. I mean, I've worked for vendors all my career. If I'm a person developing the software in a PLC and whatnot, I'm staring at a CWE talking about, I don't know, cross-site scripting or cross-site request forgery. These are vulnerabilities that my software developers should be looking out for when they're writing the code. But this list here, you've sort of connected it a bit to compliance. Do end users use this list? What good is this list to an end user? Or is it primarily a tool for developers to say we should be on the lookout for these 700 different things in our source code?
There are several different use cases for CWEs, and you're right, Andrew. It is a very valuable, useful resource for DevSecOps, especially from a shift left perspective when they're looking at cyber-informed engineering or secure by design of the devices. Being aware of the CWEs during the continuous integration and continuous development of OTICS device firmware code. But beyond that, if you are an asset owner and let's say that you have just completed your asset inventory, it is typical that 20 to 40% of your assets may be end of life or legacy assets. And it's no longer being supported by an OEM, but it is still in production. It's still connected to your network. And you will want to either A, hire a threat hunter, threat modeler, to look at the firmware of those end-of-life devices to see if there are any of these CWEs that are in the firmware. That can be done through reverse engineering. It can be done through binary analysis scanning to see if these CWEs are present in your firmware. What actions you take after determining if there are any potential 0 days in your firmware is to either A, triage that end-of-life asset for replacement, or work with your OEM provider to see if there are any remediation steps to be taken. But the other way of handling that is fencing the device, much like what Waterfall does with providing directional communication to an end-of-life device to protect it from exposure to a cyber attacker. So there are many things that both an asset owner and an OEM manufacturer can take in reducing risk if a CWE has been identified.
This sounds almost too good to be true. If I've got a list of, I don't know how many hundreds of potential weaknesses, and I've got scanners available that can scan my firmware. I mean, let's say I'm a vendor, can scan my stuff and come back and say, here's all of your vulnerabilities, fix them all. Now my code has none of these vulnerabilities. The only thing I'm exposed to is, I don't know, misconfiguration. Someone puts a weak password in, or new kinds of vulnerabilities being discovered. It sounds really good. Is this how people use this?
Quite truthfully, Andrew, there are no silver bullets out there for doing binary analysis and finding 100% of potential 0 days or CWEs. And not all CWEs are even exploitable. So even after you find a CWE, could a hacker get to it? Is there a path to it? So you really have to use the scanning as a part of your full stack when you're looking at your vulnerability management. You're using your SBOMs. You're using your hardware bill of materials. You're looking at endpoint protection. You're looking at network monitoring. You're looking at the configuration of the assets. You're making sure that that your vulnerable assets are fenced properly, that the information is being properly fed to your SIM or your SOAR so that you can trigger security policies to keep an eye out on access to your more vulnerable or end-of-life or legacy assets. You want to add threat intelligence to your stack. You want to add potential membership into an ISAC that is sector specific to what you're involved in. There's, also the great capabilities that AI is adding to industrial automation, looking for anomalies within the code. So this is just a part of your full stack, but I'm advocating not to miss the ability to proactively look for potential 0 days in addition to monitoring for bad behavior on your network, because often by the time that you see the bad behavior on your network, it may be too late. So add both proactive detection as well as responsive detection. An additional part of that full stack is also digital twins. Digital twins are not only providing value for mechanical asset integrity, but also from a cybersecurity standpoint. It's providing that redundancy and resiliency for your critical infrastructure environment to then apply patches or to then have discussions on remediation for these potential 0 days, triaging your end-of-life asset replacement strategy. So I just want it to be viewed and not be glossed over. There's a lot of value in knowing whether or not there's potential 0 days that are sitting in your firmware.
Okay, so you've covered a lot of ground in terms of where CWEs might add value to a defense in depth posture. Can I give you a concrete example? Can you walk me through? Assume, let's say that I am, a medium impact power plant. That's what personally I'm most familiar with. NERCSIP. I've got to comply, means I've got to do a risk assessment, a security assessment on my system. I don't know. What is it? Every 18 months or something like that, whatever the rule is. And let's say as part of that, I bring in, an outside assessor. They come in and, very carefully run, I don't know, Nessus or something. And, on all of my 100 PLCs and HMIs and everything else. And it comes back and says, you have 3 vulnerabilities you didn't know about. These 3 PLCs have a vulnerability. It's in the CVE. It was added 10 days ago. And I go, what? I'm not supposed to have any of these. Quick, put a plan in place, patch this, figure out if I have to report this to the regulator, and another sort of a month or 6 weeks later, when the patch has been tested, it's been rolled out, I'm done. I am aware of no vulnerabilities, no CVEs that are evident in my asset inventory. I'm clean again. But I've learned about CWEs, and I go look at the CWE database, and it doesn't have the name of my PLC in it. If I have that sort of, let's say, NERCSIP infrastructure in place already, how would I use a CWE?
That is an absolutely fabulous question, Andrew. And I think that's a lot of where companies, they think that if they've handled all of their CVEs, that they can call it a day. And it is, definitely a step forward in saying that you've eliminated all of your CVEs. That's, a fabulous accomplishment. But again, the CVE is a published vulnerability. It is not going to recognize a potential 0 day. And if you look at your OT threat report that you did, your 2023 threat report, some of the attacks that were reported were actually taking advantage of 0 days and not published CVEs. So you're not finished after you patch and remediate all of your CVEs. It is important to do a deeper dive and do vulnerability scanning of your firmware looking for CWEs. That responsibility can be delegated to your third-party vulnerability management provider, your compliance provider. It can also open up dialogue with your OEM manufacturer relationships that you have. But, the importance here is that you don't stop just at the CVEs or the KEVs, is that you do continue down the path of being proactive and seeing if there are any CWEs that reside in your assets.
Okay, so maybe another way of asking the same question. Let's take the other extreme. I have, I don't know, a shoe factory with hundreds of PLCs in it and other robots, and I know that I have hundreds or even thousands of instances of vulnerabilities. This PLC that I have 73 of has 19 vulnerabilities that I know about, and I just haven't got around to patching it. So I've buried these vulnerable PLCs behind 6 layers of firewall and some encryption and some antivirus and some intrusion detection, and I already know that I have thousands of CVEs that I haven't patched. Does CWE do me any good? How mature do you have to be before you can get some benefit out of a CWE scanner or approach or whatever it is?
I think just about any critical infrastructure can take advantage of it. I wouldn't necessarily place a shoe manufacturer as being critical infrastructure. So, if you look at the digital grid, power generators, electricity providers, you're looking at wastewater, treatment plants, you're looking at nuclear power generation, or anything that could affect national security, chemical refinery plants, because, you're looking at highly targeted sectors for potential terrorism. Those are the low-hanging fruit of sectors that take the most advantage of what we're talking about. So the more mature, critical infrastructure providers.
So, Andrew, in its simplest form, CWEs and CVEs, they're both tackling ultimately the same sorts of software bugs, but CVEs from the after-the-fact perspective, known vulnerabilities, you deal with them in turn, and CWEs, as she mentions, are the more proactive, the looking for the things that will one day be CVEs if not dealt with today.
Indeed, but to me, CWEs highlight sort of a very common blind spot that I see in engineering teams. I see way too many people, often technicians, sort of people hands-on, lower down, nose to the grindstone, make this stuff happen, focused on known vulnerabilities. And the calculus in their mind sort of goes, well, if I can patch all of my vulnerabilities, if I can get rid of all of my vulnerabilities, then I am invulnerable. And they work really hard to patch everything. And, the whole system is sort of blind to the fact that, well, that addresses the known vulnerabilities, but who knows what's out there on the unknown side. And CWE is sort of a tool that, once you have a glance at it, you go, there's hundreds of these things. There's hundreds of potential problems going to bite me. If the bad guys find these before I do, before the good guys do, before there's a patch available, then we're in trouble. So to me, CWE sort of is a powerful way of reminding people that it's not just about patching. There's bigger fish to fry here. There's sort of more dangerous scenarios that are possible.
And this isn't to undermine the necessity and the difficulty in patching everything, but it strikes me that maybe part of the problem is that it's simply easier to conceive of all of the known vulnerabilities than to creatively address and go through all of the things that you don't know about.
That's right. And, it's, to me, part of the problem is the term vulnerability. When CVE uses the term, most of the vulnerabilities in the CVE database, tens of thousands of them, are bugs in the software that can be patched. If you look at the definition of the term vulnerability in the 62443 standard, it's defined as any way that a system can be compromised. Many of which are, bugs in the software that can be patched, but others are configuration mistakes, are stolen passwords, are default passwords, are, any of the many ways that you can attack a system without exploiting a software vulnerability. But the fact that they use the same word for both of these is very confusing. We had Eric Kosman on like a year ago, and he admitted, look, this is, there's confusion in the industry. Vulnerabilities are bigger than software bugs. And again, CWE, reminds us about software bugs we haven't even seen about. But the bigger picture is, we need to be concerned about all of the ways that we can be attacked, not just exploits of known vulnerabilities. We do need to address those exploits, that possibility. I don't want to belittle that. It's a very hard problem to solve, but the security is bigger than that, is sort of the lesson, and CWE is one of the ways of reminding us of that. And you've been working with this concept with end users like this for some time. Can I ask you, when you look at at CWE, you said there's scanners available. If you run one of these scanners on, a system that is, has a bunch of known vulnerabilities and a plan to get rid of them, and, has already got rid of all of the other known vulnerabilities, and you run one of these scanners and you come up with, what do you come up with? How many instances do you come up with? How unhappy are these owners and operators to discover that there's more to do? Can you talk about the experience of working with CWE?
Finding a CWE is not the end of the world for the OEM or the asset owner, and it provides a great collaborative opportunity. I was just included in, just listened to a podcast from Dragos, for instance, that was using the use case of working with Rockwell Automation, where they discovered some CWEs that then goes through the reporting exercise of actually CWE is a precursor to a CVE. I didn't explain that earlier, but you have to find a CWE. You have to determine it is exploitable. You then discuss it through either CISA as the root management of that CWE for the OTICS sector. And then once it's been communicated to the OEM, they're given the opportunity to remediate, and then it becomes a named CVE. And Dragos is a CVE naming association, or is also referred to as a CNA. They went through the whole scenario of finding CWEs associated with Rockwell Automation devices or assets, and found it to be a very positive, collaborative discussion where Rockwell was very proactive in coming up with remediation before it was published. So it can be a very positive activity in finding a CWE, because it only reinforces our critical infrastructure cybersecurity position.
I've led development teams for much of my career. We were responsible for products that had hundreds of thousands, sometimes several million lines of code in them. And in spite of our best efforts of, me and every one of my development teams, every piece of production product that we released had bugs in it. There's a certain defect density depending on how vigorously you test, vigorously you inspect, vigorously you design the code. In spite of your best efforts, there's always defects residual in the code. More defects in larger artifacts as a rule than in smaller artifacts. And some of those defects are security vulnerabilities, just statistically. And, some of those vulnerabilities we've discovered or are going to be discovered by the good guys and are going to be fixed by the good guys before the bad guys find them. Some of them, potentially the bad guys are going to find and use against us before we have a chance to patch them. This is sort of back of the envelope. This is my personal experience. This is sort of principles of software development. In practice, you've been using these scanners. You've been using CWE. How if I scan a random HMI with 2 million lines of code in it, do I find 0 days?
Typically, the older the device or asset is, the more likely you are to find CWEs in it. Because, chances are it wasn't included in a cyber-informed engineering program or a secure by design program. So yes, you're going to find CWEs. The chances of those CWEs being exploitable is then the next step that you take. So it's not a doomsday message that every asset is going to include a CWE that's exploitable. So that's why the importance is to triage it based off of resiliency and how old the asset is and if it's being connected to the network. So there's a lot of different factors on whether or not you even want to do this scanning on it. But you also need to prepare for how you would respond if these assets or these 0 days are actually hacked. So getting involved in incident response training programs like the ISA's ICS for ICS, where teams can be focused on the forensics of the 0 day attack and how to respond to it, how to protect yourself from that going forward, and most importantly, how to prevent it by being proactive. And so there's a high connection between doing CWE scanning and awareness of 0 day vulnerabilities with your incident response training program.
Andrew, how do you prepare teams for scenarios where a 0 day vulnerability is uncovered and now you have to, rush to patch everything?
That's a good question. I wish I'd asked Susan that question, but sort of off the top of my head, there's a couple of things you have to do. We talked about sort of the definition of vulnerabilities. It includes 0 days. It includes other kinds of misconfigurations or attack opportunities. 0 days specifically, to me, there's a couple of things. You got to look at the big picture and anticipate the possibility in your designs and in your risk planning. When a 0 day is announced, let's say there's occasionally an announcement saying, here's a CVE, a 0 day is being actively exploited and there's no patch available for it yet. It's sort of an emergency announcement. So that's not really incident response. That's sort of emergency management in the entire program. The intrusion detection vendors will rapidly produce a signature for the vulnerability being exploited. What bytes have to come across the network to exploit it. You can put that in place to see if you're being attacked. You might add even a drop the connection rule to your firewall. It says if I see a packet come by and match the signature, it's called virtual patching. Even before a patch is available, you can hopefully prevent the attack propagating into the vulnerable system. You can take other mitigations. You can say that subsystem that has the vulnerability is not vital to operations. I'm going to disable it, for a week and live without it until a patch is available. But more to your point, my guess is that if there's an incident in progress, you got to deal with the incident no matter how it got in. But at some point, you want to find out how did they get in. Because once we've, shut everything down, cleaned everything out, we don't want to start it all up again until we know the bad guys aren't going to get in 5 minutes later. And so the forensic analysts, while we're cleaning things out, they are analyzing the data, trying to figure out how did they get in. And, we have to design our systems so that these incident responders, the forensic analysts, have the information, have enough information to be able to figure out how this happened. And that means, detailed audit logs, if we can, on all of the devices, especially the Windows and the Linux machines, so we can see what did the user, do on the compromised machine to bring about these undesirable results, escalation of privilege or whatever. Some sites keep, networks, just keep keep copies of packets on their networks, or keep copies of packets on their networks that came in through, let's say, the firewall interface. Keep them for a long time. It means a huge amount of storage, but it does mean that in an emergency, your forensic team has a fighting chance of going back through those packets and trying to figure out when did the attack come through, and what did the attack look like, so that they can figure out what kind of vulnerability has been exploited here, and report it to the authorities and put measures in place. So, long answer, it's this is sort of what it means to have a security program and a response team aware of the possibility of 0 days, and especially the 0 days in the CWE catalog. Well, Susan, this has been tremendous. I learned something. I didn't even know that CWEs existed. Thank you for this. Before we let you go, can you sum up for us? What are sort of the main messages? What's the one thing we should remember from this episode?
Thank you, Andrew. The one takeaway that I'd really like listeners to have is to be proactive instead of just being responsive. If you look at the overall NIST framework of being able to, detect and respond, I think it's really important to be proactive in your overall cybersecurity program. Know your assets. I think that a lot of times, if the larger the critical infrastructure is, the greater the chances that you don't know every single asset in your infrastructure. And then even more so, triaging the assets based off of resiliency and having a focus on your end of life or legacy assets that are still in production, still connected to your network. And because they're end of life, you may not have had a patch even available to you, or support of that asset available to you for some time. And it represents the danger of a 0 day lurking within your infrastructure. And CWEs give you that opportunity to really do a deep dive into those triaged assets to see if you've crossed all your T's and dotted all your I's from a compliance perspective. So if any of the listeners want to get involved with the Mitre CWE ICS working group, I'd encourage you to do that. It's a great group to get involved in. Also, reach out to your compliance service providers when you're looking at your compliance alignment, and introduce this concept when you're looking at your vulnerability gap analysis and your asset inventory management. And feel free to reach out to me. I'm on LinkedIn. My LinkedIn is Susan Farrell. So it's linkedin.com/n/Susan Farrell. And I look forward to discussing any of these topics with you.
Andrew, that concludes your interview with Susan. Do you have any final thoughts to take us out today?
Yeah, well, there's something new in my understanding of the world. CWEs, common weaknesses. They strike me as more useful for mature organizations that are looking forward at what might come at them versus less mature organizations that are just getting started. Strikes me as very useful for developers. A long list of stuff to look for, to watch for, to avoid when we are developing industrial products. Increasingly, sort of as an aside, a lot of modern developers are thinking about problems like this, and they're using tools like writing their products where possible in Java or other languages that just Java manages memory automatically. Other languages manage other kinds of things automatically. Takes entire sets of possible vulnerabilities off the table. But the CWE repository strikes me as, it reminds us of the potential for new vulnerabilities coming at us, especially in older gear whose developers weren't looking at their code this way, weren't thinking about all these kinds of things when they developed those products that a lot of us are still using. So a useful resource.
Okay, well, with that, thanks to Susan Farrell for speaking with you, Andrew. And Andrew, as always, thank you for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.